today we're going to be partitioning when multiplying again. Yesterday we were doing things like 7 times 6 and breaking up the 7 into a 5 and a 2 and breaking up our array that way. But today we're going to do a bit bigger numbers because really you should know 7 times 6. And partitioning we really are going to use a lot more when in multiplying when we have a double-digit number by a single-digit number to make our lives a little bit easier. Okay, so if I'm looking at my question here, it's 14 times 4, right? So I've got 14 across the top and 4 down the side. 4 down here, so 14 times 4, or 14 lots of 4, or 4 lots of 14, however you want to talk about it. And what I'm going to do, instead of figuring out 14 times 4, because I don't really want to count up in 4s 14 times, I'm just going to draw a line right 1, 2, 3, 4 after 4 of my columns here. And then all of a sudden, I don't have 14 times 4, I have 2 separate arrays. On one side, I have 4 times 4, so 4 across the top times 4 down. And over here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 4. 10 across the top and 4 down. Okay, and just like we did yesterday, all I'm doing is I'm partitioning my 14 into 2 bits. I'm partitioning it into a 10 and a 4. All right. So now all of a sudden, I don't have to solve 14 times 4. I can just solve 4 times 4 and 10 times 4. So if I am going to do that, remember I put them in these wee brackets to show that they're separate parts, and then I'm going to add them together afterwards. So 4 times 4 plus 10 times 4, and I'll solve them independently. So 4 times 4, as you know, is 16. And 10 times 4 is 40. Just a quick reminder that if you have any number at all and you're scaling it up by 10, so you're multiplying it by 10, you're just moving it one column to the left. Okay, so that 4 becomes 4 tens, and then we need a placeholder here in its place, and it becomes 40. So any number times 10, just scoot it over to the column on the left, which is the tens column, and then add a placeholder in the units. So we've got 16 plus 40, and then 16 plus 40 is equal to 56. So 14 times 4 is actually equal to 56. Now I have a similar problem. I have 17 times 6. I've used rods here instead of counters because it's just a little bit easier to get it sorted. So what we have across the top here is we have a 17, okay, and then I have 1, 2, 3, 4, 5, 6, so 6 groups of 17. And what I'm going to do is I'm going to partition my number because, again, I don't want to count up 17 in 6s 17 times. So what I'm going to do is I'm going to just split my 17 into a 10 and a 7 to make my life a little bit easier. And it's really easy to see that with the number rods. So here it's quite visual. I have 10 lots of 6 on this side. So I've got 10 times 6. And then I have 7 lots of 6 on this side. And all I have to do is solve them independently and then add them together. So again, if I'm going to write this out properly, I'm going to write in brackets 10 times 6. I'll move that up here where it should be. So 10 times 6 plus, then in brackets again, 7 times 6. And I'm going to have 10 times 6 again. If I'm here and I've got 6 units, which is what I'm starting with, and I'm multiplying it by 10, I'm just scooting everything over one column to the left, so I end up with 6 tens instead of 6 units, and I have 0 as a placeholder. So I've got 60, and then 7 times 6 is 42, and 60 plus 42 is 102. So 17 times 6 ends up being 102. If you're at school and you have access to rods and you want to build it with the rods so that you can see it a little bit better, go for it. If you're not and you want to draw a wee diagram, go for it. If you're not so great at your times tables like 7 times 6, again, you can use a wee strategy to help you. So doubles, maybe 7 times 3 and then double it. Or you could split that up into 2 times 6 and a 5 times 6 and then add those two together. It's really up to you. There's lots of different ways that we can do this, all right?